Hello everyone. This is next lecture in your cloud computing only. Let's discuss about TNet networks. Okay, so TNet network are created by user for connectivity with projects. They are fully isolated by default and are not shared with other projects. Networking support a range of telnet networks. Type flat, all instances reside on the same network, which can also be shared with the host. So here you can see in this on your screen, telnet network is there, and this all. Okay, so let's discuss about this. You can see here WAN, public network, general routers, right? Is there. So here multi-tenancy cloud computing. A multi-tenant cloud is a cloud computing architecture that allow customer to share computing resource in public or private cloud. Each telnet data is isolated and remain invisible to other telnet. In telnet cloud system, user have individual space for sorting their projects and data. So telnet networks, OpenStack TNet networks. Here, the OpenStack networking is both love and hate. To make sure you have means you have more of the former experience than the latest. You should get your feet wet as soon as possible. In this section, we shall run through some simple telnet network configuration. First, through you need to understand the basic difference between how traditional flat. Okay, networks are configured for virtual and physical machine, and how OpenStack networking will be demonstrated. The team flat refer to absence of the virtual routing tile as part of their virtual server platform. In traditional configuration, the virtual machine has direct access to network as if you plug a physical device into physical network. Okay, so here network connected to physical router. As you can see here, the network is connected to the physical router. Okay, so in this type of deployment, all network service like dynamic host configuration protocol, that is called DHCP, load balancing, routing, and so on. Beyond simply switching, open system interconnection, that is open system, like short is OSI, open system interconnections model layer must be provided outside of the virtual environment. For most system administrator, this type of configuration will be very familiar. But this is not how we shall demonstrate it. The power of OpenStack, you can make OpenStack networking. We have like traditional flat network, but that approach will limit the benefits of the OpenStack framework. So we discussed about in last lecture only OpenStack framework, OpenStack networking, right? So here you can make OpenStack networking behave like a traditional flat network, but that approach will be limit benefit of the OpenStack framework. In this section, you shall build OpenStack 10 network, okay, TNet network from scratch. So here, difference between the more traditional network and type of network you shall build. So that compared to traditional flat network and the OpenStack TNet network includes additional router that reside within a virtual environment. The additional of virtual router in the separate internal network show general network from external network. Public network virtual machines communicate each other. Okay, so network and virtual router. This is the general router. Use external network for communication outside the TNet. So here in this diagram, you can see this keystone is there, right? So domain quota proxy. So you have Nova, cinders, nova, and cinder is there. So here domains for driver is there. Region 1 and region 2. This keystone is divided into two parts, region 1 and region 2. Okay. So here design the purpose of have two main blocks. One in keystone we are calling the domain quota proxy, DQP. The other we are calling domain quota driver, DQD. So first is called DQP, that is a proxy, and another is called driver. Okay, so here this is comes proxy and drivers. Okay, DQP and DQD. Okay, so one is called proxy and drivers is divided into two parts. Okay, so here, so two main block is there, as we can see here in keystone. We are calling the domain quota proxy DQP, and we are calling domain quota driver the other. Okay, so DQP, that is domain quota proxy, is responsible to give to the user 1.2 domain quota management. So it acts as a proxy. The DQP is a discrete extension that can be improved to save to server as single point of management for other quota. The DQD, that is a domain quota driver, is a piece of code located in the quota module of Nova. Cinder and Quantum project and its design is the same fashion as the other drivers present in such a module. Quota modules need to be reflected and add DQD, that is the domain quota driver. Also, we should extend the services REST API to provide domain quota uses. Domain quota proxy, the DQP is designed to be implemented as discrete extension and not include in the default pipeline of Keystone. So here the domain quota driver DQD design is a similar to current quota driver from quota p.py module, that is a extension of this. So given possibility to user to option to use it or not. So they will be responsible to enforce all quota listen in the table above in the context of domain. So the quota define the resource uses limit. The set of 10, the Oracle Cloud Administrator determine the quotas, TNet topics of discover the quota gate. So here, okay, quota in Nova. So let's discuss. So TNet quota, the modify quota setting, you shall need to know TNet ID. You want to work with the user ID. Okay, that's currently in that tent. The following example show you list all tents the system and find the ID. So dev stack at the dev stack, last lecture we have seen the comments. So this dev stacks at the dev stacks keystone tnet dash list. So using the command interface, you can manage quota for the OpenStack compute service, the block storage service. Typically, default values are changed because the TNet requires more than one OpenStack default of 10 volume per TNet or more than OpenStack default 1 TB of disk space. So Nova uses quota system setting limits on resource such as number of instance or amount of CPU that specify project or user can quota limits. The use can be retrieved using the commands and limit interface. So here quota in Nova. Okay, quota in Nova you can see in this diagram. So Nova use a quota system for setting limit on resource as number of instance or amount of CPU that specify project or user can use. Quota are enforced by making a claim or reservation on resource. When So here, so as you can see in this diagram, this is the diagram of this. Okay, so let's discuss. So quota in Nova. Nova uses a quota system for setting limit on resource, such as number of instance or amount of CPU that a specific project or user can use. Quota are enforced by making a claim or reservation on resource when request is made, such as creating a new server. If the claim fails, the request is rejected. If you reservation succeeds, then the operation progress until such as point that the reservation is convert into uses. The operation was successful or rollback operation fail. Okay, so typically the quota reservation is made in a Nova API service and uses roll or rollback is a perform in the Nova compute service, at least when dealing with the server creation or move operation. Quota limit and uses can be described via limit REST API. So checking quota here. So when calculating limits given resource, 10 the following checks are made in order depending on the resource. In there, 10 specific limit on the resource in either the quotas or project user quotas table in the database. If so, use the limit. You can create the resource by doing. Okay. So architecture of the neutron. So reference neutrons you can see here. Architecture of the neutrons. Okay. So so the architecture of neutrons is simple, but it with the agent and plugin where the real magic happens. Neutron architecture has been present in the following diagram, which you can see on screen. So neutron server, the function of component is to be phased to either neutron environment of the outside world. It essentially made of three modules: REST service, the REST service L2 agent means REST service. The first module is here REST service. Then second you can see here, as you can in diagram you can see 1 minute, LG2 and LG3. Okay, so okay, let's take this both together. Okay, just 1 minute. Okay, okay. Okay, so let's discuss Nova volume network and compute queue database AMQP SQL Nova schedule Nova API. Okay, so here L2 L3 is there, so we have to discuss both. So this is means able to see is very clear, but here see here user OpenStack API or Amazon EC2 you can see here. So here Nova API is there. Okay, then here Nova schedule there, then here AMQP SQL that he in under this SQ and database is there. Database you know very well the meaning of database. Okay, the Nova network volume and compute. Okay, so here arrows there backward and forward all are there. So this is about the Nova's architecture. Let's discuss about this. Okay, so, okay. Let me minimize this. It's very clear cut. Okay. Okay. So here, so let's discuss about now. Neutron server. The function of the compute is is the face of neutron environment to the outside of world. So REST service. The REST service accept API requests from the other component and expose all the internal working detail in the term of networks. Okay, so subnet, ports, and so on. So it is a application written in a Python uh, and uses in 96 form communication. So RPC service, the RPC service communicate with the messaging bus, and its function is to enable agent communication. So then plugin is a base described as a collection of Python module that implement standard interface which accept this service receive some standard API calls and connected with device downstream. They can be simple plugin or can implement drivers for multiple classes of devices. The plugins are further divided into core plugin, which implement the core Neutron API, which is a layer 2 networking, and IP address is a management. If any plugin provides additional network service, we call it service plugin. For example, balancing as a service, that is LBAS, load balancing as a service, firewall as a service, that is FBAS, firewall as a service, and so on. As the example of module layer 2 is a plugin framework that implement device and perform the same function across ML2 networking technologies commonly used in data center. So L2 agent, as you can see in this diagram only, L2 agents, L3 agents, and this one. Okay, so L2 agent runs on a hyperversion compute node, as its function is a simply or a wire new device, which means it provides connections to new server in appropriate networks, okay, segments, and so on. Provides notification when device is attached to or removed. In our install, we will use the OVS agents, and L3G agent runs on a network. Okay, L2 agent runs on a hyperversion, that is compute node and function and its function. And L3 agent is runs on network node and responsible for static routing. So you know very well static and meaning of dynamic. So IP forwarding and other LT features such as understanding the basic neutron process. Okay, so here let's discuss basic neutron process here. So let's take a quick look at what happened. The VM boots with Neutron. This follows steps that boot VM start, that is virtual machine, then create a port and notify a DHP of the new port. Then create a new device and virtualization libraries. Write a port and complete boot. So explanation of architecture here. So this is about now. This is about we have discussed this. Next, discuss about this architecture. ओके आई थिंक सो अभी आप दिख रहा होगा ठीक से सो Nova architecture. Nova is the architecture as a distributed applications with many components, but major of this custom written Python demands of two varieties: web server gateway interface, that is called WSGI, web server gateway interface, application to receive, and media API call, worker demands to carry out tasks. So there are two essential pieces of the architecture that are neither custom written nor Python based: the messaging queue and database. So this two component facility means messaging queue and database, as you can see here in diagram only, messaging queue and database. Okay, queue and database here. So the two components that is facilitated are asynchronous of complex tasks through message passing and information sharing pieces. This all together we get in this picture only, that is in this diagram only. This complicated diagram can be summed up in this sentence. End user who want to use Nova create compute instance call Nova API with OpenStack API or API request. Nova demons exchange informations through the queue and database to carry out the API request. Glance is a completely separate service that Nova interface through the Glance API to provide virtual disk imaging service. Nova that we have seen the overview of process and their instance. Let's take the closer look each other component. So API. The Nova API daemon is the heart of Nova. You may see in this diagram only on many Nova as API and cloud controller. While this part through the cloud controller is really just a class, so its primary purpose is to accept the fulfill incoming API request. Scheduler. The Nova scheduler process is conceptually the simplest pieces of code in Nova. It takes virtual machine instance request from the queue and determine where it should run. A computer server host it should run on. So in practice, however, they will grow to get to be most complex pieces as needs to factor in the current state of the entire cloud infrastructure and apply complicated algorithms to ensure efficient uses. The end Nova scheduler implement pluggable architecture lets you choose or write your algorithm for scheduling. So computer workers, the Nova computer process is primarily a worker daemon that creates terminate virtual machines instance. And the process by which it does not fairly complex, but bases are simple. Accept function from the queue and the perform one series of series virtual machines. API calls to carry out while updating state in the database. Example, this will be Nova Compute, accepting message from the queue, create a new instance using the KVM instance. So volume worker, as you can gather, the name Nova volume, message, the creation attaching the of the precedence volume to compute instance similar to the functionality of Amazon Elastic Block Storage. It can use volume from variety of providers such as OAOE. Network workers. The Nova network worker daemon is very simple to Nova compute and Nova volume it accepts network tasks from the queue and perform system command to manipulate the network, such as setting up bridge, interface, or changing rules. Nova defined two different types of IP address. For instance, fixed IP address and faulting IP. So this can be broadly through as private and public. I mean, the fixed means private and broadly means faulting means sorry floating matlab publicly. Okay, so fixed IPs are Nova network divided by two networks में fixed and floating. Fixed comes to under private and floating is public IPs. So fixed IPs are assigned on instant startup and remain the same during their either lifetime. Floating IPs are dynamically allocated and associated to domain to allow the outside connectivity. And what let's see discuss about queue, which is given in diagram only. The queue provides central hub for passing messages between demos. Okay, so this currently implemented with the today's means currently implemented here. So but cloud any AMPQ message queue support by the Pythons. Just 1 minute. Okay, queue here. The queue provides a central hub for passing message between. This is the currently implement. Okay, so here Nova creates a several type of message queue or facilitate the communication between various. Include the queues format. Queues is means like is used for hosting purpose. Then these queues allow to message to broadcast to the number of particular class or workers. Okay, so database here. The database stores most of the configuration and runtime state for cloud infrastructure. This includes instance type of the available for use, instant in use network available and projects. So what are the building blocks of cloud computing? Okay, the building blocks of cloud computing here. This is this three soft, very well, SaaS, PaaS, and IaaS, which we have discussed previously many times, right? So, what is a private cloud here? The private cloud, also known as the internal cloud or corporate cloud, is a cloud computing environment in which all hardware and software resources are dedicated to and accessible only by single customer. The physical layer consists of the hardware resources that are necessary to support the cloud service being provided and typically includes server storage and network component, and abstract layer consists of the software deployed across the physical layer which manifests the essential cloud characteristic. So three different layers in cloud computing, that is the infrastructure cloud, abstract application from server and server from storage, content cloud, abstract from application. So let's discuss here, which is the layer here given. This is the building block is having three layer: physical layer, virtual layer, and cloud management layer. Okay, let's discuss this point first. So what is virtual layer? Specific kind of the vectors layer allow you to define a layer as the results of advanced query using SQL language on any number of other vendors layer that is able to open this layer are called virtual layers, and they do not carry data by themselves and can be seen as a view to other layers. What is virtual environment in cloud computing? So virtual is a cloud computing is making a virtual platform, server, operating system, and storage device. This will help user provide a desktop machine, and same time it also allows sharing single physical instance resource application to multiple users. So here ये क्या help करता है to provide a multiple machine at the same time and allow the sharing single physical instance. तो वो sharing purpose है multiple machines provide करने के लिए we are using this. और यहाँ पे types we have know already, we have discussed about this, that is the desktop virtualization, application virtualization, server virtualization, network virtualization, storage virtualization. So what are the virtual system? Virtual system is a virtualization technology that divides a physical device into multiple independent logical devices. Each virtual system function are real uh, as a real device has own resource and runs its own service, which can be independent, configured, and managed by the administrator. So, what is a cloud management layer in cloud computing? The cloud management layer enables you to deliver tenants with automate workload provision by using self-service portal. So cloud management design details. So what is the management layer? The management layer display the real time status on every configured solutions. Okay. So here and solution object, and you can activate and deactivate solution and single application from the layer application layer. So control and monitoring also includes user defined solution. So what is a key functionality? Cloud management platform. The key functionality of cloud management platform here, you can say that organization to deploy, manage, monitor, and control application across public and private clouds, sure that companies can achieve both cost and agility savings. So, futures of cloud computing platform is general service. The user cloud have access. Okay. Okay, futures platform cloud management uh, capability general service. The users should have access to self capability reporting, service management. Team should be able to monitor service in the cloud, resource management, financial management, governance, and security integration. So, how cloud management is done? Cloud are pools, virtual resource storage application and service that are managed by software. So the resource can be accessed on demand. Cloud management is a combination of software, automation, policy, governments, and people that determine how does cloud computing service are made available. So what are the three type of management? So here all management style can be categorized by three major, like you can demonstrate autocratic and license fair. So the three level of management typically found in organization are two level management, middle level management, top level management. So virtual private cloud is implemented using shared data center infrastructure of hardware and software. Okay, just 1 minute. So here a virtual private cloud is implemented using shared data center infrastructure of hardware and software. The data center is mostly likely of permis is shared with the multiple organization. If data center is not shared, that is a private cloud. The upper layer of the cloud computing stack, that is a PaaS and SaaS in a virtual private cloud, is dedicated to the organization. The lower. So the upper layer of the cloud computing, so the virtual private cloud may participate in hybrid cloud. The following figure use custom relationship management software service to virtual private cloud. So private cloud management tools is a management often use house tools such as the cloud can include platform specific management software such as the operation manager and so some private cloud management tools offer sophisticated software framework to manage the complex private and hybrid cloud deployment. These tools include Microsoft System Center Virtual Machine for Hyper. Okay, so this is about your cloud computing today's lectures over here. Thank you.